Hello everyone, welcome to my channel Chemistry is Fun. Today we will deal with the chapter States of Matter. Now see, first of all we have to find out what is a matter. Anything which has mass, anything around us which has mass and it can occupy some space is called as a matter. So it means that it should have some mass and definitely it should occupy some space. Then it is matter. Matter can exist in three physical states, that is solid, liquid and gas. Among these, liquid and gases are called as fluids because they can flow. They are able to flow. They don't occupy a confined space. So they are the fluids. All these three states of any substance can be changed into one another if we change the temperature and pressure. Now, let us look at some common characteristics of the three states of matter. We start with the gases. The atmosphere around us is a mixture of gases. The gases do not have any definite shape or any definite volume. They have no definite shape and they have indefinite volume. That is, they have no definite volume. They are having disordered particles. The particles are arranged in a disordered manner and the particles are always in random motion. There is no orderliness. Since they occupy more volume, the density is low. Because in the gases, the intermolecular forces of attraction is very less and the intermolecular space is more. Intermolecular forces of attraction is very less. So the molecules are far away and the intermolecular space, that is the space between two molecules, is very high. So they have a very low density. Since the intermolecular space, that is, these are the molecules, they are very far apart. If we apply some pressure, they can be forced to come closer together. So the gases are compressible. And as I told you, they can flow, so they are fluid and they diffuse rapidly. One gas can diffuse into another gas very fast because intermolecular space is very high. Next we see the liquids. The liquids do not have any definite shape, but they definitely have a volume. Volume is fixed in case of liquids. The intermolecular force of attraction is higher than in case of gases, and the kinetic energy of the molecules is little less than gases. If we see the compressibility factor, they are less compressible than gas. These are also fluids. They are able to flow because the molecules are not rigidly held at their places. Next, if we compare the solids have a definite shape, they have a definite volume. The particles are orderly arranged. There is an ordered arrangement. The molecules are very close to each other. Intermolecular space is very less. If you see, these are the molecules, they are very close to each other. Intermolecular force of attraction is very high. The space between the particles is very less, resulting in very high density. Since there are very less gaps between the particles, we cannot compress them. They are already very close to each other. How to bring them more close? So they are nearly incompressible. Now, one by one, we will discuss in detail all these states of matter. First of all, I will be dealing today in gaseous state. Gaseous state is also a very big topic. There are many gas laws. So I will complete the different laws in my subsequent videos. Today we will be studying Boyle's law. But before that, let us see the important features of the gaseous state. As I told you, the gases in the case of gases, the particles are very far away from each other, so they can be brought closer, so they are highly compressible. Whatever volume is available, they can expand without any limit. They occupy the full volume available. If the gas is kept in any container, they apply some pressure, that is exert pressure on the walls of the container in which they are kept. If there are two gases kept, they can diffuse rapidly through each other. So they form a nearly homogeneous mixture, because you see, if these are the molecules of one gas, there is so much of intermolecular space. So here this space can be occupied by the molecules of some other gas. So diffusion is easy here. So homogeneous mixture means exact homogeneous they may not be making, but more or less we get a homogeneous mixture after diffusion. If we want to describe the characteristics of the gases, we need to explain four important parameters. They are volume, pressure, temperature, and amount of the gas. Now if we see volume, the volume of the gas can be explained by the volume of the container, because whatever container is made available, the gas will expand and it will use the full volume available. Volume can be expressed in units like liters, milliliters, or cubic centimeter or cubic meter. 1 liter equal to 1000 ml. 1 liter is equal to 1000 milliliter. Like that, conversion is possible. So we can find, if we know the volume of the container, we can easily find out the volume of the gas. Next is pressure. Pressure is, the gas will exert some force, as I told you, on the walls of the container. So the force exerted per unit area on the walls of the container, if this is the container, we consider one unit area. On that, whatever pressure is being applied, that is whatever force is being applied per unit area of the container wall, will constitute the pressure of the gas. In order to measure the pressure, we can use instrument called manometer. There are two types of manometers, open-end manometer and closed-end manometer. Now, pressure of 1 atmosphere can be defined by the pressure which can support a column of mercury of height 76 centimeter. In a tube, if we take mercury to a height of 76 centimeter at 0 degree C, then whatever pressure is required to support that will be called as 1 atmosphere. 1 atmosphere is also equal to 760 torr. 760. 1 atmosphere is equal to 760 torr. torr. 1 atmosphere equal to 760 torr. TORR. But the SI unit of pressure is Pascal. SI unit of pressure is Pascal. Pascal is the pressure which is exerted when a force of 1 Newton acts on a 1 square meter area. When force of 1 Newton acts on 1 square meter area, then the pressure is equal to 1 Pascal. Force of 1 Newton acts on an area of 1 square meter, then the pressure constituted will be termed as 1 Pascal. Force of 1 Newton acting on 1 square meter area constitutes a pressure equal to 1 Pascal. There is also another unit which was earlier used called bar. 10 to the power 5 Pascal. Older unit of pressure is bar. Bar is equal to 10 to the power 5 Pascals. Next parameter is temperature. Temperature of any gas is measured in Celsius degree. It can be measured with a thermometer. The SI unit of temperature is Kelvin. Kelvin also known as absolute degree. Now Kelvin is equal to degree C plus 273. So if we have temperature in degree C at 273, we get Kelvin value. K equal to degree C plus 273. Next is amount of the gas. So we can express in either mass or in moles. So mass of the gas can be expressed in grams or kilograms. We know 1 kg equal to 1000 gram, that is 10 to the power 3 grams. But if we have to express it in number of moles is the mass in grams of the gas given divided by its molar mass. That will give moles. And one important feature is that all the gases obey some laws which are called as the gas laws. Among the gas laws, today we will be discussing about first law, that is Boyle's law. It gives a relation between volume and pressure of any gas of a given mass at constant temperature. It states that if the temperature remains constant and the mass of the gas also remains constant, then the volume of the gas sample will vary inversely with the pressure. Inversely means when the pressure increases, the volume should decrease. That is inverse variation. So we can say that if we are increasing the pressure at a constant temperature on a particular sample of a gas, proportionately the volume will decrease. So if we double the pressure, volume becomes half. If we are doubling the pressure, the volume will become half. So based on that, this definition is given. That is, at a constant temperature for a given amount of gas, the volume of that sample of the gas will be inversely proportional to the pressure. So we can also state the same thing in a different way, that at a constant temperature, the product of pressure and volume of the given mass of gas remains constant. So if initially the pressure of the gas is P1 and at that time the volume is V1, and then we change the pressure, volume also changes. So now the new pressure is P2 and the new volume is V2, but the product of pressure and volume before and after changing will remain constant. We can graphically represent this law. If we plot a graph between the pressure and volume, you see, we get, this is the first curve, this is the curve. Here temperature and mass being constant. This is the variation of volume with pressure of a gas at a constant temperature. This is also known as isotherm. This curve we call as isotherm. So this is the curve. Next, if we plot graph between V and 1 by P, this curve, it shows relationship between volume and reciprocal of pressure. Volume and reciprocal of pressure, it is a straight line. This confirms that at constant temperature, volume of a given mass of gas is inversely proportional to the pressure, because we are getting a straight line. Here temperature and mass has to be constant. Next, this is another third graph. Here the third curve shows a straight line. This straight line is parallel to the pressure axis. Straight line parallel to the pressure axis. It confirms that the product of PV, product of pressure and volume of a gas at a constant temperature is constant. You see, PV, if you are increasing the pressure also, P into V is same, because when we are increasing the pressure, proportionately V will decrease, keeping PV constant. So we are getting a straight line parallel to the pressure axis. Now, location of a straight line will change if we change the temperature. See, we add temperatures T1, T2 and T3. This is the graph exhibiting the relation between P and 1 by V at different temperatures. As we increase the temperature, T3 is the highest temperature. You can see T3 greater than T2 greater than T1. We get this type of curves if we plot P versus reciprocal of volume. All are straight line, but the location changes. Once we change the temperature, this is how the relation will be for the different values of temperature as predicted in this graph. So here P is inversely proportional to V, or P is equal to K into 1 by V. Whenever we want to remove the proportionality, we have to multiply with a constant. So this is the constant K. Based on this Boyle's law, we can have a small numerical. Now see, there is a gas and it occupies a volume of 10 liter at a pressure of 1 atmosphere. Now when the pressure is doubled, pressure becomes 2 atmosphere, what will be the volume? Temperature being constant. So now we have to write down the values. Initial volume V1 is 10 liter. V2 we have to find out. Initially pressure P1 is 1 atmosphere. It is increased to 2 atmospheres. So P2 is 2 atmospheres. As per the Boyle's law, we know that P1 V1 equal to P2 V2. So from here we get V2 is P1 V1 by P2. Putting the values, we get that P2 is 5 liters. I hope all could understand the topics which I have discussed today. Thanks for watching my video. Please subscribe to my channel. Thanks for watching. Thank you.